Hello everyone. Welcome back to the class of probability with Mopia ma'am. Today we are going to learn addition and multiplication theorem of probability, and we will be solving some problems on based of those theorems. So let's begin our class. Here is the addition theorem of probability. It says that for any two events A and B which are mutually exclusive, the probability that either event A or event B occur is summation of their individual probabilities. That means the probability A or B equal to probability of A plus probability of B. Take an example of rolling of a dice. Probability of getting two numbers, for example, 2 and 5, probability of getting 2 or 5 is equal to probability of getting 2 plus probability of getting 5. These two events are mutually exclusive, and on these mutually exclusive events only we can apply this formula. This formula can be stated as this one also, and the symbol is termed as A union B. Let's move forward to solve some problems. A card is randomly drawn from a deck of 52 cards. What is the probability of getting a queen, king or a queen? So this is an example of mutually exclusive event. As we can get only a king or a queen, we cannot get both at a single draw. So total number of cards are 52. Total number of king cards are 4, as there are 4 kings only in a pack. So probability of getting a king is 4 by 52, as you all know, which results into 1 by 13. And in the same similar fashion, we have calculated the probability of getting a queen card, which is also 1 by 30. Then, clearly the events of getting a king or queen are mutually exclusive, and we are applying the theorem of addition here to get the probability of getting either a king or a queen. Let's see. So probability of getting a queen or a king is probability of getting king plus probability of getting queen, which are 1 by 13 plus 1 by 13, that is 2 by 13. Let's move to our next example. A number is selected from the first 25 natural numbers. What is the probability that it would be divisible by 4 or 7? Here also the numbers are mutually exclusive. If we are selecting one number, we cannot get two numbers at a time. Let's see. Here the total numbers are 25 in count. Let A be the event that the number selected would be divisible by 4. So we have to find out within the range 1 to 25 how many numbers are there which are divisible by 4. Let's have a look. In the set of A, there are 4, 8, 12, 16, 20 and 24. These numbers are divisible by 4, and these are 6 in count. So probability of getting a number which is divisible by 4 is 6 by 25, as the total numbers are 25 in count. So B is the event that selected number would be divisible by 7. Here these numbers are 7, 14 and 21. Only 3 numbers. So probability of getting a number which are divisible by 7 is 3 by 25. These two events A and B are mutually exclusive, as there are no common numbers in their respective sets. Hence, probability of getting A or B, that means probability of getting a number which is divisible by 4 or 7 is probability of getting a number divisible by 4 plus probability of getting a number divisible by 7, that is probability of A, and plus probability of B, which results into 9 by 25, as you can see here. Now we will be moving forward to know the multiplication rule of probability. So the multiplication rule of probability states that the simultaneous occurrence of two events that are independent in nature is given by the product of their individual probability. Rolling a dice to get a number, suppose 4, and taking a card out of a deck to get a 4 of spade are individual of each other in nature. So multiplication theorem is applicable here. For any event A and B, the probability that event A and B both occur is represented by probability of A and B equal to PA into PB, which is also represented by the following symbol, where the symbol is termed as A intersection B. Now let us solve a problem with multiplication rule. A bag contains 4 red balls, 3 green balls, and 5 blue balls. 2 balls are drawn one after another with replacement. Find the probability that the first is red and the second is blue. Here, mind the term with replacement. With replacement means first we are taking out one ball from the bag, we are seeing the color, and we are putting it back inside the bag and mixing it with other balls. So let's find the solution. So the bag contains 12 balls in total, 4 red, 3 green, and 5 blue in color. Probability of getting a red ball in the first draw is 4 by 12, as there are 4 balls, 4 red balls, and 12 total balls. Probability of getting blue ball in the second draw, there are 5 blue balls, and after taking out the first ball, we are replacing it inside the bag. So the total number of balls are 12 only, and these two events are becoming independent. Since the events are independent, the probability that the first is red and the second are blue will be calculated by multiplying their individual probabilities, as you can see here. And the result is 5 by 30. I hope all of you have remembered that we have solved few problems with help of a tree diagram, right? So while we were calculating the probabilities of the final outcomes, we were using this same multiplication rule. Thank you all.